Hello, my name is Michael Doran. I'm a California attorney. The name of the show is Convergence. I'm here to talk to you about climate change. I'm looking to find a conversation with the public, and I think I have something very, very novel to say. I heard recently Mitch McConnell say that if the Democrats try to run on climate change, the Republicans will win. My perspective is a little bit different. For 25 years I've been studying this and been part of different debate bulletin boards, and I've noticed that the debate has become very stagnant, particularly among the contrarians, is what I call them, not skeptics anymore, because no one really has taken any skeptical positions of what they have to say. And this is a kind of conversation that's, and a discussion that's almost impossible without starting in the middle of the conversation, almost like there's no starting point to it. But there kind of is a climate history, and I do want to talk a little bit about it at first here and focus on different things per show. And then as we get going along, hopefully if you're following, and please follow and click the like button, you'll find that it becomes more interesting. So don't be afraid at first to kind of be snowed a little bit. I've been studying this for, like I said, 25 years. I've been part of different debate groups, and I certainly myself started out very confused. I was a warmer at first, and then I did not join the skeptics rank and caught a lot of crossfire. The first thing I think is important to understand what the history of the greenhouse gas theory is. And with that, you have to start with a scientist by the name of Charles Keeling. He's a Scripps professor, and he missed the births of his children, and he went to the volcano in the Hawaiian Islands and climbed up on top and put an apparatus that measured carbon dioxide. And while he was doing this, his children were born, and he missed their births. He was a very dedicated scientist. He's written books. He's gone now, but he's the first one to have tracked the carbon dioxide levels globally. And from that, many people who had been talking about it already surmised that CO2 was a greenhouse gas and was causing all kinds of climate change. It was causing global warming. And the idea of that is that CO2 is like if my head is an oxygen molecule, and I'm sorry, a carbon molecule, and my hands are two carbon molecules. When a light photon hits carbon dioxide, it causes it to move and to translate, and that movement is known as heat. And that heat, that infrared energy, can bounce off other air molecules and heat it up. The problem is pretty textbook stuff when you begin to debate this, is that you're talking about 4 watts per meter squared. So if you have a column of air and it goes all the way down, it's going to trap about the carbon dioxide in the air, which is a trace gas. It's 4 parts per million. It's going to trap about 4 watts per meter squared. And it's not just a straight 4 watts per meter squared with the amount of carbon dioxide that we've burned into the atmosphere from outside of the biosphere from fossil fuels. It's a difference between what was there and what is now, what's not being absorbed by the atmosphere, and what's not being absorbed by the biosphere, and what is being injected into the biosphere outside of the active biosphere. So that change, that difference, we're at about 400 parts per million now, and during pre-industrial age we were about 270 parts per million. That change we're talking about is what has less than 4 watts per meter squared. Now, I know that number isn't meaningful to you, but the problem is clouds like cirrus clouds trap 200 watts per meter squared, and clouds like fog reflect 100 watts per meter squared. So just that tiny differential is only a small part of what is supposedly causing this change. And for this reason, most scholars who study the weather, warmers or skeptics, or something else like me, will talk about water vapor as the main greenhouse gas, and that's what's trapping the heat and causing the change that we're going on, or that we're seeing. But there's people that don't agree with that either, and they talk about how the ocean is coupled with clouds, and they start getting into cloud behaviors, and still that discussion that's being had about cloud behaviors is about how heat is trapped or stored, or whether it is released out into space. And so I want to talk about this in terms of where we were in the 80s, when this 70s and 80s, when people started talking about it. I know I started to get it in my geology class in college in the 80s. I'm 60 years old. And it hasn't changed that much since. But the idea is that the atmosphere is warmed by carbon dioxide trapping heat in this differential, and then it causes a water feedback, which is heating the Earth, and heating the oceans, and melting glaciers, and everything else. And we're having kind of a divergent opinion that's going with among the people, the so-called skeptics. They were convinced around 2000 that the CO2 as a greenhouse gas didn't make any sense. But the warmers, people who believe that climate change is occurring and is occurring because of carbon dioxide as a greenhouse gas, those people have a lot to see with their own eyes and experience with their own eyes. They see the changes going on quite obviously. And they typically, you can't argue with the theory, because you can't be a skeptic of the theory, because so much of it is obvious. So that's where I kind of want to start, is when skepticism sort of didn't meet skepticism and became more of a contrarian position, often a position that was sponsored by the very people that were accused of causing the damage to the environment, and go over one particular scientist's work and talk about it as kind of a starting and a background to where I'm going with it, which is completely different. And the paper I want to talk about, and I know at first this is not going to be particularly interesting stuff at first, as we start to see that there actually is some controversy here, and there's new science, and versus kind of a static debate that CO2 is a greenhouse gas, and isn't it obvious? Look around you. Where there isn't any debate, there's just kind of an observation, and when are we going to do something about it, and what are we going to do about it? As opposed to some skepticism about mechanism, and then not only skepticism about mechanism, but then what we can do about it, and that there are more specific things that we can do about it with what we're going to be talking about. But again, to start in the middle of the conversation, I guess you'd have to go back to the history of climate, and where some of the skeptics were hail from. One of the first places, again in the same kind of period of time, was a gentleman by the name of John Daly. I was on one of his listserv with him for some while, and he was a very conservative person who is a so-called skeptic. He got a number of people on his website called Still Waiting for Greenhouse, and I think his daughter still runs that website. But he passed away again in the early 2000s, and he believed again that CO2 was not a significant forcing on climate, and it was things like the sun and so forth. And because he was from Australia, he's very familiar with El Nino, or the El Nino Southern Oscillation, as it's sometimes called. And this was important to the Australians because they wouldn't get good rain, typically unless there was an El Nino, and where they would run their cattle, because most of Australia is very arid, where they would run their cattle would depend very much whether or not there was an El Nino. If there wasn't an El Nino, or if there was a neutral condition, you'd have different conditions for clients. So what the Australians started to do, they were seafaring, and they were capable of getting information. The barometric pressure was something that wasn't invented yesterday. It was invented some time ago. And there's literally over 120 years of data. And what it is, it's an index, the SOI index, which is El Nino, ENSO, El Nino, this oscillation. And what is this oscillation? It's just two data points. One is in Tahiti and the other is in Darwin, and it's an index of barometric pressure. And based on that, they felt long running, and I'll have some explanation why there's some meaning in the short run to it too. But and the website itself says, don't look at the short term, only look at the long-term averages. But the idea is that when you get a sustained wind blowing, say, to the west, that can blow warm waters across the tropics and into the western Pacific, and bring certain conditions, and then water being blown the other way can bring other conditions. And most people are familiar with what an El Nino means. It means warm waters in the tropical eastern Pacific. So that's kind of the background. And there's one more thing I want to talk about too, and that's this idea of Mr. Lovelock, who's a Gaia proponent. His story is called Daisyland, and the idea is when the Earth got hot, it would open up white feathers and reflect back all the heat, and when the Earth got cold, it would open up black petals and warm the Earth up. And his ideas, he's 102 years old. He's famous for his Daisyland theory. He's an electrical engineer, really, by training. But he came up with this idea, again, involving CO2 as a greenhouse gas. And his idea was criticized when it came out in the 80s or so forth. And it was criticized because it takes 600 years for carbon dioxide to come naturally out of the atmosphere. And that was way too slow to have a biological feedback. And so in the academic circles, his idea was roundly criticized. And so with that background, I want to talk about a paper that created a tremendous amount of controversy around the year 2000, a little bit after that. This paper was published in final form September 29th, 2000, and the paper is entitled, it was published in the Bulletin of American Meteorological Society. Does the Earth have an adaptive infrared iris? It's written by Richard Lenzine and also co-authored by Mingda Chow and Arthur E. Y. Hu, H-O-U. And it's a study that looked at the western tropical Pacific where El Niños form. And it looked at degree by degree grid squares and came to some conclusions that upset a lot of people. And I first want to talk about the title and again where he studied this so-called infrared iris. Again, it was just north of Australia. This is from the paper itself. To the tropical Pacific that often becomes active with tropical storms in the Western Pacific storm season, but also is very unique for the El Nino and how an El Nino looks at it. And what the study involved is satellite data, again split into 1 by 1 degrees over a time period. And what he was looking for specifically is what are called cloud-weighted SSTs. Specifically was looking at cirrus clouds and tropical storms. And what they saw, or what you think they saw, was that the canopy of cirrus clouds over tropical storms got progressively bigger the colder the oceans, pardon me, the oceans were. This is interesting because CO2 is a greenhouse gas that should warm up the air the more and capture more air and cause more cloud cover. The warmer things are. So this idea really was skeptical of the greenhouse gas theory, and so his idea was that, again, the Earth had this adaptive infrared iris. And let me segue just a little bit. And again, this is very difficult because we're going right into the middle of the conversation. There are many people who advocate for fossil fuels that climate is essentially chaotic, that inputs come into the climate system. We certainly get order with chaos theory, but and stabilities, and things like adaptiveness, depending upon how cold the oceans are, things like that. That kind of an argument. And the idea is that it was random in the past. There's inputs into the climate system, and it's random. And it's random in the future. So you might as well go ahead and burn fossil fuels because it doesn't matter. It's going to, some kind of an outside event, some kind of chaotic event is going to hit the Earth and change everything. It's also known as catastrophism. Now, eventually you'll see that I advocate something completely different. I advocate that the Earth is alive and that it's a dampened system. Kind of like when I'm hot, I sweat, or cold, I shiver. And so it's interesting that the title of the paper is, does the Earth have, blah, 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 an iris, something alive that adjusts the light? And that's the kind of question that is being asked by people who kind of look at things statically as opposed to dynamically. They're asking about light adjustment, heat being trapped, but not about heat pumps. And this is we'll get into this in great detail. But for right now, it's just this living thing that is adjusting the amount of light to and from the Earth. And CO2 has this role as a greenhouse gas. So this is what he's testing with this paper. And what he comes to a conclusion is basically that the oceans aren't really coupled with what's going on with the clouds. And I would take it even a further step. And I'm going to draw a simple sine curve and show you what that looks like. And I'm going to put El Nino on the top of the curve and La Nina on the bottom of the curve. Just a very simple idea. So, and I don't know if you can see this, but this idea of a just simple sine curve with the top of the curve El Nino and the bottom of the curve La Nina. And we've been having these El Ninos every 2 to 5 years for the past 4,000 years. How do we know this? Well, there have been many studies, but one in particular that I read was of a lake bed in Ecuador where they did coring, and during an El Nino, it gets rare rain, and it causes sediment to flow into the lake, and you can see the sediments, and what you see is like clockwork El Nino every 2 to 5 years, going about 4,000 years, and then before that, El Nino was every 17 years, and then during the glacial, no El Ninos at all. So, what does this curve kind of tell you? One thing it tells me, and this again is a very simple model at this point, is that if you take the second derivative of sine, it's minus sine. So I'm going to draw that for you. The second derivative looks like, again, this is crude, but what it says is when El Nino is at its warmest, it's cooling down at the fastest rate. So its change, its rate of change is the most intense when El Nino is peaking, and then during La Nina, it's warming up the very most. And in conjunction with what, you know, I don't know exactly what Dr. Linzin's ideas were. He was the advisor of climate for George W. Bush, who is very much respectfully in the pocket of big oil. He worked for big oil. And so he had a skeptic, which Richard Linzin was, in charge of climate and the concerns that people might have over climate. He had a skeptic. And so this is the big paper that he wrote. And the reaction to it was a little surprising in that scientists like Hartmann and Fu looked at the satellite data all across the tropics, not just in the part of El Nino where El Nino occurs. And they concluded that the ocean was in fact warming across the tropics. And so here's my problem with it. So I'm going to start talking about a totally different mechanism to CO2 as a greenhouse gas. I'm going to start talking about CO2 as predominantly interesting in clouds, specifically in clouds that are supercooled and they're going from water to ice. And clouds that have carbonation in them that are freezing like that in the context of large-scale, low-frequency electromagnetic waves. I know it's a handful, but we're going to see tremendous amount of evidence, number of papers as the series goes on, and then you're going to get daily examples of how this is occurring and what the incredible and terrifying implications. And I've actually talked to Richard Linzin on the phone, and one of the words that came out was alarmist. And I was thinking to myself, wow, I'm an alarmist. But it's actually kind of understandable, because if you take what is being observed and you think of it as just a chaotic oscillator or something that has its own order, that's self-correcting, then what we're actually seeing is some pretty incredible stability that climate has. And that's because it's dampened. When I'm hot, I sweat, cold, I shiver. We keep coming back to body temperature. And if you look at it like that and not really understanding what the mechanism, you think this is a very stable system, and there's nothing to get all worked up about a trace gas. The flip side of that is that because it's a dampened system, because it's so stable, it's been stable for so long, at least 4,000 years. And it's a living system. It is subject to broken feedbacks, or what I call, just like any disease, a defect in a feedback loop. And that, again, as the show goes on, I want to talk about that. Okay, this is enough for today. I wish you good luck, and I hope you stay with me. Click the like button and add to the debate in the comment sections. This is going to be a very unique forum in terms of skepticism. I believe real skepticism is going to be allowed here, and I think I have a lot to add to the discussion. I've been doing this, studying this, and writing about it, and talking about it for 25 years. Thank you for your time.